Do you know for over 4.5 billion years, Earth's core has burned like a massive cosmic furnace? But why hasn't it cooled down yet? In the beginning, Earth formed as a molten ball of rock, after countless space collisions generated unimaginable heat. As the surface slowly cooled, the inside remained blisteringly hot, storing the planet's earliest formation heat deep below. This trapped heat couldn't escape because Earth's outer layers act like an enormous insulating blanket. Deep inside, the core is made mostly of iron and nickel metals that hold heat extremely well under pressure. The biggest heat source is radioactive decay. Atoms deep inside Earth naturally break apart and release constant energy. These tiny decays from elements like uranium and thorium generate non-stop heat every second for billions of years. This heat rises through the mantle in slow-moving plumes, but the process is so slow the planet cools incredibly slowly. Another source is pressure heating. The deeper you go, the more intense the pressure, creating heat through compression. In Earth's center, pressure is 3 million times higher than the surface, squeezing atoms and generating additional heat. And although Earth loses heat, it escapes at such a slow rate that the core remains incredibly hot. Volcanoes are tiny windows into this heat, but they release only a fraction of what lies beneath. The outer core is fully liquid, constantly swirling in giant loops of molten metal. These moving metals produce electric currents that generate Earth's powerful magnetic field. Earth's core literally creates the magnetic shield that protects us from the sun's deadly radiation. The inner core stays solid because pressure forces atoms tightly together, even at extreme temperatures. Around it, the outer core stays molten because pressure there is slightly lower, allowing metal to remain liquid. This slow-rising heat drives mantle convection, the engine behind earthquakes and drifting continents. Plate tectonics, the movement of Earth's continents, is powered directly by the heat from deep within. Despite cooling for billions of years, Earth still holds more than half of its original internal heat. Planet-sized bodies cool extremely slowly because heat takes immense time to move through thick rock. Smaller planets like Mars cooled faster, but Earth's larger size helped it stay molten inside. Earth's dense metal core stores heat efficiently, slowing the cooling process even more. From the core to the surface, each layer slows heat loss, acting like insulation in a giant planetary furnace. Earth loses heat into space, but only gradually, much slower than it generates new heat. Scientists estimate Earth's core will stay molten for billions of years into the future. As long as the core stays hot and liquid, Earth's magnetic field will continue to protect us. The molten outer core behaves like a vast ocean of liquid fire, constantly churning and releasing energy. And all this heat is the reason Earth remains geologically alive, vibrant, and constantly changing. So Earth's core is still red hot because leftover formation, heat, radioactive decay, crushing pressure, and slow cooling all work together to fuel a fiery world beneath our feet.